Hi everyone, welcome to my channel. In this video, we are going to continue with our file system concept. In the last video, we understood what is file system and what are the types of file system. Along with that, we also understood what is the three-layered structure of Linux file system. Today, we are going to understand about FHS in Linux, which stands for File System Hierarchy Standard. Okay, what is this? FHS in Linux defines the directory structure and contents of a Unix-like operating system. Think of it as a blueprint that tells Linux where everything belongs from system binaries to user files. It ensures consistency across distributions, which means that every major Linux distributions like Ubuntu, CentOS, Fedora, Debian follows the same basic directory structure and file placement rules. Imagine switching from Ubuntu to CentOS. Even though they are different distros, you'll still find config files in etc, user data in the home directory, system binaries in bin or user bin, logs in where directory. So in short, we can say that FHS makes Linux predictable, portable, and easier to manage no matter which flavor you are using. Let's check on what all directories are present in most of the distros. As I said in last video, that everything in Linux is a file which starts from, or we can say which are under the forward slash r, that is root. You can see all the directories are under this root slash. This means that this super person has the power to access any of the directories available under the structure. Let's check on what all files present inside this root. I need to go to root directory. So I'm going to change directory using this. Now, if you check pwd, you are under root directory. Now, you want to check what are the directories of files present within this root directory. You can see these are the folders available under this root directory. Okay. So, in most of the distros, you can see these folders which serves the same purpose. So, first, let's check what is bin directory. Okay. Bin, it contains essential user binaries, which means it contains all the commands needed by all users and system admins. For example, the command which we use to list the files or to show present working directory, or we can say any other command that we use on daily basis, those commands lives in this place. Okay, so let's see how what it means. So if you go and check, if you go to the directory bin, you can see these are the contents of bin directory. So these are the actually commands, but they are not command, they are file. As I said, Linux consider everything as a file. So you can see all the commands which we use on a daily basis, the user and the system admins, those files, those commands are living here. So if you delete any of these commands, or then what happens? Those commands cannot be used as it should be used, right? So we should not delete any of the commands. This is just a place where these commands live, where all the what we can say coding for that commands are written in these files. So you can see normally all the commands like cat, pwd, ls, grep, everything you can see under this directory. Same way we have sbin. Uh, It contains essential system binaries, which includes the commands which are used by only system admins or the root users. It contains the administrative tools used for system setup, maintenance, and recoveries. So, bin, what is the difference between bin and sbin? Bin is the place where all the commands reside there. Those commands are used by system admin as well as the users. But sbin is the place where the commands live which are used by only the system admins. So this is the main difference between bin and sbin. So for example, if you want to reboot the system, this cannot be done by the user. This is done by only the root or system admins who has the privileges of roots. So those commands are placed in this directory sbin. Next directory is the boot directory. The boot directory in Linux is like a launchpad for your operating system. It contains all the critical files needed to start the system before the main OS takes over. It includes the grub bootloader configurations and essential kernel files that are loaded during startup. It's better that you don't touch this until it's actually necessary. Next, dev directory. The dev directory contains device files, which are special files that represent physical or virtual devices on your system. These aren't regular files with data, they are interfaces to hardware or kernel services. We mean that they act as gateways, which are special files that let users space programs communicate directly with hardware devices or low level systems functions. For example, if suppose we have a file like dev/sda, which doesn't contain any data like text file. Instead, it represents your hard disk. Some dev files doesn't represent physical devices. For example, we have a null directory which discards anything written to it. It is like a black hole managed by the kernel. We have another example which is random. It gives you a random numbers generated by the kernel. So these files are not just the storage, they control points and they let you interact with the system at a low level. We can give one more example. For example, you just think dev SDA like a remote control for your hard drive. You don't open TV to change channel, right? You use the remote. Similarly, you don't poke the hardware directly. You use dev files to send commands through the kernel. We have two types of dev devices. One is character devices, another is block device. Character devices in which data is transferred character by character. Here, there won't be any buffering, which means it doesn't store the data, it directly processes the input output. For example, if you type on a keyboard, each keystroke is sent immediately to the terminal via dev TTY. The example which we can see are keyboards, serial ports, mice, mouse, etc. These files are identified by C character. If you check by LSLTR, you can see C, right? So these devices are character devices. Next, device in which the data is transferred in blocks. It is a buffered access where the data is stored in chunks. Example, 4 KB of blocks are stored in one block before being written to disk. Example, we have hard drives, USB sticks. We can identify this kind of devices by using B. So here you can see B, which means this is a block device. Next, we have etc directory. The etc directory in Linux is like the brain of your system's configuration. It holds all the system-wide configuration files that control how your operating system and services behave. It is short for editable text configuration. Some may say it as a etc. Some say it as etc. And some even say it etc. All are same. We have etc password directory where all the user account information will be available, like username, what is UID, what is the home directory in it. Check what is there inside password file. So you can see these are the data available inside password file. You can see the last entry, which is Ubuntu. So this is the user. Ubuntu, who, whose home directory is home Ubuntu. It has shell script bin bash. So likewise, we have many files under this directory in which only the configurations are mentioned. We have etc fstab, we have etc host name, host for local DNS resolution, etc network for network interface configs. Any misconfiguration here can affect booting, networking, or service behavior. It's often the first place sysadmins looks when troubleshooting. Learn what is lib directory. Lib directory in Linux is like a toolbox that supports the system's core functionality. It contains shared libraries and kernel modules that are essential for booting the system and running basic commands. It holds shared libraries used by binaries in bin and sbin. These libraries, like plugins or helpers, they contain reusable code that programs can load dynamically. Let's learn what is media. A media directory in Linux is designed as a mount point for removable media. like USB, drives, CDs, DVDs, and external hard disk. Think of it as the parking spot where Linux temporarily places external devices when they are plugged in. When you insert a USB stick or CD-ROM, Linux automatically mounts it under media username or media slash device name. This makes it easy for user and application to access the contents of removable devices. It is useful to keep removable media organized and isolated from systems directories. In simple term, we can say it as a temporary mount directory for removable devices. Next, we will learn what is mount. The MNT, mount directory in Linux, is a generic mount point, a place where you can manually attach or mount external file system like USB drives, network shares, or ISO images. Unlike media, which is used automatically mounted removable devices, MNT is typically used by system administrator for manual mounting. You can create subdirectories inside MNT to organize mounts. Example, you can create backup file inside MNT or ISO file inside MNT or NFS file inside MNT. Main difference between media and MNT in Linux comes down to who mounts the device and how it's managed. Both are used for accessing external or additional file system, but they serve different purposes in the Linux system. Media, which is used for automatically mount removable devices, whereas MNT, mount directory, it is used for manual or temporary mounting by admins. It is reserved for only the system administrator to manually mount file systems. What is home directory? The home directory in Linux is like your personal workspace, a dedicated area where each user stores their files, settings, and preferences. Understand about home directory, let's create an user. Sudo user add -m demo1. So I'm adding a user with name demo1. So it has been created successfully. Now let's check what are the users under home directory. So ls home, you can see last time it was only Ubuntu. Now I've created two users, demo1 and Meenakshi. So likewise, the root user creates the user and the users will be added directly with the home directory. They will have their own space in which they will create a file. They will do whatever they want to do in their personal space. Now let's see what is opt folder. Opt stands for optional. The opt directory in Linux is like a VIP launch for third party or optional software. It's designed to keep external applications separate from the core system, making your environment cleaner, more organized, and easier to manage. It is used to install add-on software packages that are not managed by your system package manager like apt, yum, or DNF. It is ideal for self-contained apps, those that come with their own libraries, binaries, and configs. For example, if I want to download any custom DevOps tools, right, that is not available in apt or any package manager, you could install it like by creating a folder under opt folder and copying all the config files, executable files, library files into that optional, what we say, opt folder. What will do, it will directly run from there and you can work with that app without having that package manager. If you want to uninstall that app, very simple, you can just remove it by using rm command. But you should have a privileges. Only if you have the root privileges, you can delete it. This makes it no dependencies mess and no system pollution. Next, let's check what is user directory. The user directory in Linux is like the library and toolbox for user level application and resources. It contains read-only data binaries, libraries, documentations, and source code for programs that are not essential for system boot but are used by users and application once the system is running. Mostly they call it as user, but actually it stands for Unix system resources. It's often mounted as a separate partition and treated as read-only. Next, we have var directory. The var directory, which stands for variable in Linux, is like a system's dynamic workspace. It holds data that changes frequently as the system runs. And it's used for logs, caches, mail spools, and other files that grow or shift over time. Unlike directories like user or etc, which holds static files, var is designed for mutable content, data that's written to, updated, or deleted during normal system operation. For example, if you want to check login attempts, so how you can check? You can go to variable directory. From there, you can check what is going on under log auth.log. So here you can see all the logs present to see what is the authentication, who did what in this logs. Or if you want to check what is the system messages to monitor it. So we have another place where syslog. For example, you can do tail f log syslog. Oh, sorry, it should be log. So you can see all the information related to what is the system messages to monitor it. Status code 400. So this is what real-time monitoring logs you can view under var.log, var/log. So these logs are actively updated by the system and are crucial for troubleshooting, auditing, and monitoring. Let's see what is temp directory. The temp directory is a temporary directory in Linux. It's like a scratchpad for the system and applications. It's where the temporary files are stored during runtime. These files are short-lived, often deleted automatically on reboot and used for things like installation processes, session data, or unsaved work. It is used by both the system and the user application to store files that are only needed for a short time. For example, if you are editing a document in LibreOffice, while you are working, it will save the auto recovery files in temp. If the system crashes, you can recover your work from there. But once you save and close the document, those same files are not needed and it will be deleted automatically. This is what the actual work of temp directory. Let's see what is sys directory. Sys directory in Linux is part of the sysfs virtual file system and it acts like a real-time dashboard into the kernel's view of your system's hardware. It's not just for reading, it's also interactive, letting you tune system behavior and monitor devices directly from user space. What is proc? The proc directory in Linux is a virtual file system that acts like a live dashboard into the kernel. It is not stored on disk, it's generated in memory at boot time and constantly updated to reflect the current state of your system. Think of it as a Linux real-time control center for processes, hardware, and kernel internals. It's mounted at proc and contains text files and directories that expose system and process information. Each running process gets its own folder named by its PID. Example, you can see these numbers are the process ID. You can directly use this process ID to check the information related to the computer, CPU, the state of the system, everything. It also includes system-wide files like proc CPU info, proc mem info. You can see here is a memory info, devices, everything you can just look into it. Now, if you want to check CPU information, have to check it cat and then CPU info. Here you can see all the details about your processor model, cores, cache size, etc. See the status of this process. You just can copy that process, and then boom, you can see the status of the process in the first line. You can see it's sleeping. So this is where all the information related to your process, related to CPU, memory, everything you can see it under proc directory. Last directory which we are going to learn today is root directory. The root directory in Linux is the home directory for the root user, the system's super user with unrestricted access. It's not the same as slash, which is the root of the entire file system. Think of root directory as a private workspace for the administrator, just like normal user whose personal space is home directory. It's the default home directory for the root user. It is only accessible by root or users with elevated privileges. It is used for storing scripts, config files, backups, or logs that are relevant to system administration. These are the major directories you'll find across most Linux distributions. They may look different, but their purpose stays the same. Now that you have decoded the Linux directory structure, you are not just using the system, you are mastering it. Keep exploring, keep scripting, and let the file system work for you. Thanks for watching. If you have any doubts, drop a comment below. I'll be happy to answer. And if you found this video helpful, please share it with others and don't forget to subscribe for more tech insights.